This is the golf problem from the Idiot's book, that is Statistics for Idiots. I have invented a golf ball that I claim will increase your distance off the tee by more than 20 meters. I run tests on a sample group of 40 golfers and find that their average increase is 22.5 meters. Suppose the standard deviation of the population is 5.3 meters. Do I have enough evidence to support my claim with alpha equal to 0.01? How do we start the solution to this? Here we don't see a population mean in the problem description. That is because this is what is called a research claim, i.e., here we are claiming that our research gives evidence of an increase of greater than 20 meters. To support our claim, we must reject the opposite with data from our sample set. So the null hypothesis is the opposite of an average increase of 20 meters. So the null hypothesis is the average increase is mu less than or equal to 20. Now we know what to do. Once we get that null hypothesis going, we know what to do. So what do we have? We have mu is less than or equal to 20. That's our null hypothesis. That was the hard part. We're given the standard deviation, so that's sigma equals 5.3. We're given the sample mean, and so mu x equals, where is that? 22.5 meters. And we're given our significance level is a 0.01. So our confidence level is 1 minus alpha is 99%. So if we can reject our null hypothesis, then we have evidence to support our claim. That's the idea. Our sample size is 40, so we can use the z-test. That's the normal distribution. Our null hypothesis, we denote it by H0, and here it is, mu is less than or equal to 20. So our alternative hypothesis is mu greater than 20, and to prove our claim, we want to reject H0. Remember, to use the z-test, we need to find the z-score and z-critical. And we get to reject H0 if the absolute value of the z-score is greater than z-critical. If not, we don't get to reject it. Okay, the critical z-value. This is a one-tailed test because our null hypothesis has less than or equal to inside of it, not equals. So that means we can only reject H0 from one side. In this case, we can reject it if it's greater than, so that's the right side. So the right tail is the entire rejection zone, and alpha equals 0.01. So we don't divide alpha in half, and we look for the p-value in the table for 0.99. So here's our normal distribution table. These are the z-values here. These are the p-values in here. And notice that this is the second decimal is 0, 1, 2, 3. So we're looking for a p-value of 0.99. This is 0.97, so we need to go down. 0.9916. Coming back, 0.9901. So we look at z, it's 2.3, and then this is 0, 1, 2, 3. So 2.33 from the table. Or using a program and getting a slightly more accurate result, 2.3263 is our critical z-value. Now we're going to look for our z-score, and that depends on our sample data. So here is our sample data. Here are the formulas for calculating the z-score with this data. And we see that the z-score is this formula here. So the first thing we need is the standard error of the mean. And that is the standard deviation divided by the square root of n. Sigma is 5.3 and n is 40. So using a calculator, this is standard Windows calculator, we would first do 40 and then the square root and then 1 over x times 5.3. And we get 0.83800. So 0.838. And now we need to do the other part, which is 1 over that, and then times the difference between the sample mean, which is 22.5, and the population mean, which is 20. So 1 over x, and then we're going to store that here. And then we're going to do 22.5 minus 20. Probably could have done that in our heads. Times memory recall equals, so 2.9833. So here it is, 2.9833. So this is our z-score. Our critical z was 2.323, and we can see that this number is bigger than this number, so we get to reject the null hypothesis and we get to accept our claim. Let's just say that one more time, because our z-score, 2.9833, is greater than our critical z, 2.3263. We reject the null hypothesis. That is, we have evidence to support our claim that our new ball increases our distance off the tee by greater than 20 meters with a level of confidence 99%.